The energy E in joules radiated as waves from an earthquake is given by this formula: log base 10 E equals to 4.8 plus 1.5 million. Okay, for this question, part A, we're going to use the fact that, let's say, log base A times E equals to X. I hope you remember this. We went over this many times through during the review sessions. This is basically saying that A raised to an X equals to E. So A raised to an X equals to E. We're going to use this to solve for part A. So for part A, we have this equation: log base 10 E equals to 4.8 plus 1.5. Let's just keep it as 1.5 for simplicity, and then we can add the million at the end. Alright, so this is saying 10 raised to this would just equal to E. Or we have to keep the n because it's asking for it as a function of m. So 10 raised to 4.8 plus 1.5 m equals to E. We can simplify this much more if we wanted to. For example, we can take ln of both sides. Just 1 second. Equals to ln of E. And then if we do that, we can move this whole thing outside of the parentheses. So we have 4.8 plus 1.5 m times ln of 10 equals to E, and then we can divide by ln of 10 on both sides, and then we have 4.8 plus 1.5 m equals to E over ln of 10, and then we can subtract 4.8 from both sides, and then we can just divide by 1.5 to get this whole thing in terms of m. So m would just equal to 1 over 1.5 times E over ln of 10 minus 4.8. And this is rewriting the function in terms of m. I hope this is making sense. This should be easy because this is what we did about before the break, about a month and a half ago. Okay. Now, for the second part, show that when m increases by 1, the energy increases by a factor of approximately 31.6. Okay. For this question, we're going to go back to the equation that we wrote at the beginning. This one. We call the first one E2, which is when we increase by 1. And then we call the second one E1, which is when we stay at the normal pace, so we're basically not adding anything. Increase by 0, for example. Let's divide E1 by E2 over E1. You're going to see why by the end, and it's going to make much more sense. Okay, so so then on E2 we're just adding 1 to m, so let's rewrite that. So that would equal to 10 raised to 4.8 plus 1.5 times m plus 1, because this is what the question is asking. Show that when it increases by 1, the whole thing increases by 31.6. And then we divide by the thing without the m plus 1, so 10 raised to 4.8 plus 1.5 m. Okay, now we're trying to simplify this, so we know that let's say we had e raised to 2x over e to the x, we know that this equals to e to 2x minus x. We're going to use this fact to simplify this. So we know in here we know that e2 over e1 would just equal to 10 to the 4.8 plus 1.5 m plus 1.5 minus 4.8 minus 1.5 m, and the 4.8 would just cancel out with the other 4.8. The 1.5 m would cancel out with the negative 1.5 m. So the only thing we're going to be left with is the 1.5 times 1, which is just 1.5. I'm not sure why the pen is acting up, but this should be 1.5. Okay, so e2 over e1 would just equal to 10 to the 1.5, and this approximately equals to 31.5. And then if we multiply by e1 on both sides, we get that e2 equals to 31.5 e1, and this is what proves that and this gives us the answer for the question we're given, because it's asking us to show that it increases by a factor of approximately 31.6 when m increases by 1, and this shows that. Okay, thank you. Now we'll move into the next question in the next video.